Let's get the facts of identity down first. Your name is Guillaume Verdon, Gil, but you're also behind the anonymous account on X called Based Beff Jezos. So first, Guillaume Verdon, you're a quantum computing guy, physicist, applied mathematician, and then Based Beff Jezos is basically a meme account that started a movement with a philosophy behind it.
Right.
So maybe just can you linger on who these people are in terms of characters, in terms of communication styles, in terms of philosophies?
I mean, with my main identity, I guess, ever since I was a kid, I wanted to figure out a theory of everything to understand the universe. And that path led me to theoretical physics eventually, right? Trying to answer the big questions of why are we here? Where are we going, right? And that led me to study information theory and try to understand physics from the lens of information theory, understand the universe as one big computation. And essentially, after reaching a certain level, studying black hole physics, I realized that I wanted to not only understand how the universe computes, but sort of compute like nature and figure out how to build and apply computers that are inspired by nature. So, physics-based computers. And that sort of brought me to quantum computing as a field of study to, first of all, simulate nature. And in my work, it was to learn representations of nature that can run on such computers. So if you have AI representations that think like nature, then they'll be able to more accurately represent it. At least that was the thesis that brought me to be an early player in the field called quantum machine learning, right? So how to do machine learning on quantum computers, and really sort of extend notions of intelligence to the quantum realm. So how do you capture and understand quantum mechanical data from our world, right? And how do you learn quantum mechanical representations of our world? On what kind of computer do you run these representations and train them? How do you do so? And so that's really sort of the questions I was looking to answer, because ultimately I had a sort of crisis of faith. Originally, I wanted to figure out, as every physicist does at the beginning of their career, a few equations that describe the whole universe, right? And sort of be the hero of the story there. But eventually I realized that actually augmenting ourselves with machines, augmenting our ability to perceive, predict, and control our world with machines is the path forward, right? And that's what got me to leave theoretical physics and go into quantum computing and quantum machine learning. And during those years, I thought that there was still a piece missing. There was a piece of our understanding of the world and our way to compute and our way to think about the world. And if you look at the physical scales, right, at the very small scales, things are quantum mechanical, right? And at the very large scales, things are deterministic. Things have averaged out, right? I'm definitely here in this seat. I'm not in a superposition over here and there. At the very small scales, things are in superposition. They can exhibit interference effects. But at the mesoscales, right, the scales that matter for day-to-day life, the scales of proteins, of biology, of gases, liquids, and so on, things are actually thermodynamical, right? They're fluctuating. And after, I guess, about 8 years in quantum computing and quantum machine learning, I had a realization that, I was looking for answers about our universe by studying the very big and the very small, right? I did a bit of quantum cosmology. So that's studying the cosmos, where it's going, where it came from. You study black hole physics. You study the extremes in quantum gravity. You study where the energy density is sufficient for both quantum mechanics and gravity to be relevant, right? And the sort of extreme scenarios are black holes and, the very early universe. And so there's the sort of scenarios that you study the interface between quantum mechanics and relativity. And really, I was studying these extremes to understand how the universe works and where is it going. But I was missing a lot of the meat in the middle, if you will, right? Because day-to-day quantum mechanics is relevant and the cosmos is relevant, but not that relevant. Actually, we're on sort of the medium space and time scales. And there, the main theory of physics that is most relevant is thermodynamics, right? Out of equilibrium thermodynamics. Because life is, a process that is thermodynamical and it's out of equilibrium. We're not, just a soup of particles at equilibrium with nature. We're a sort of coherent state trying to maintain itself by acquiring free energy and consuming it. And that's sort of, I guess, another shift in I guess my faith in the universe happened towards the end of my time at Alphabet. And I knew I wanted to build, first of all, a computing paradigm based on this type of physics. But ultimately, just by trying to experiment with these ideas applied to society and economies and much of what we see around us, I started an anonymous account just to relieve the pressure, right, that comes from having an account that you're accountable for everything you say on. And I started an anonymous account just to experiment with ideas originally, right? Because I didn't realize how much I was restricting my space of thoughts until I sort of had the opportunity to let go. In a sense, restricting your speech back propagates to restricting your thoughts, right?
Mm-hmm.
And by creating an anonymous account, it seemed like I had unclamped some variables in my brain and suddenly could explore a much wider parameter space of thoughts.
Just to linger on that, isn't that interesting? That one of the things that people don't often talk about is that when there's pressure and constraints on speech, it somehow leads to constraints on thought. Even though it doesn't have to, we can think thoughts inside our head, but somehow it creates these walls around thought.
Yep. That's sort of the basis of our movement, is we were seeing a tendency towards constraint, reduction or suppression of variance in every aspect of life, whether it's thought, how to run a company, how to organize humans, how to do AI research. In general, we believe that maintaining variance ensures that the system is adaptive, right? Maintaining healthy competition in marketplaces of ideas, of companies, of products, of cultures, of governments, of currencies, is the way forward, because the system always adapts to assign resources to the configurations that lead to its growth. And the fundamental basis for the movement is this sort of realization that life is a sort of fire that seeks out free energy in the universe and seeks to grow, right?
Mm-hmm.
And that growth is fundamental to life. And you see this in the equations, actually, of out of equilibrium thermodynamics. You see that paths of trajectories of configurations of matter that are better at acquiring free energy and dissipating more heat are exponentially more likely, right? So the universe is biased towards certain futures. And so there's a natural direction where the whole system wants to go,
So the second law of thermodynamics says that the entropy is always increasing in the universe. It's tending towards equilibrium. And you're saying there's these pockets that have complexity and are out of equilibrium.
Mm-hmm.
You said that thermodynamics favors the creation of complex life that increases its capability to use energy to offload entropy. So you have pockets of non-entropy that tend the opposite direction.
Mm-hmm.
Why is that intuitive to you that it's natural for such pockets to emerge?
Well, we're far more efficient at producing heat than, let's say, just a rock with a similar mass as ourselves, right? We acquire, free energy, we acquire food, and we're using all this electricity for our operation. And so the universe wants to produce more entropy. And by having life go on and grow, it's actually more optimal at producing entropy because it will seek out pockets of free energy and burn it for its sustenance and further growth. And that's sort of the basis of life. And I mean, there's Jeremy England, right, at MIT, who has this theory that I'm a proponent of, that life emerged because of this sort of property. And to me, this physics is what governs the mesoscales. And so it's the missing piece between the quantum and the cosmos. It's the middle part, right? Thermodynamics rules the mesoscales. And to me, both from a point of view of designing or engineering devices that harness that physics and trying to understand the world through the lens of thermodynamics, has been sort of a synergy between my two identities over the past year and a half now. And so that's really how the two identities emerged. One was kind of, I'm a decently respected scientist, and I was going towards doing a startup in the space and trying to be a pioneer of a new kind of physics-based AI. And as a dual to that, I was sort of experimenting with philosophical thoughts, from a physicist standpoint, right? And ultimately, I think that around that time, it was like late 2021, early 2022, I think there's just a lot of pessimism about the future in general and pessimism about tech. And that pessimism was sort of virally spreading because it was getting algorithmically amplified, and people just felt like the future is going to be worse than the present. And to me, that is a very fundamentally destructive force in the universe, is this sort of doom mindset, because it is hyperstitious, which means that if you believe it, you're increasing the likelihood of it happening. And so felt a responsibility to some extent to make people aware of the trajectory of civilization and the natural tendency of the system to adapt towards its growth, and sort of that actually the laws of physics say that the future is going to be better and grander statistically, and we can make it so. And if you believe in it, if you believe that the future will be better, and you believe you have agency to make it happen, you're actually increasing the likelihood of that better future happening. And so I sort of felt a responsibility to sort of engineer a movement of viral optimism about the future and build a community of people supporting each other to build and do hard things, do the things that need to be done for us to scale up civilization. Because at least to me, I don't think stagnation or slowing down is actually an option. Fundamentally, life and the whole system, our whole civilization, wants to grow. And there's just far more cooperation when the system is growing rather than when it's declining and you have to decide how to split the pie. And so I've balanced both identities so far. But I guess recently the two have been merged more or less without my consent. So